All right, we're continuing lesson 5.4, transformations of exponential and logarithmic functions. So example 3 says describe the transformation of f represented by g, then graph each function. So just very similar to what we did in examples 1 and 2. All right, so we can see f of x equals 3x and g of x equals 3 raised to the 3x minus 5 power. All right, so this is our parent function, and this is our transformation. So it says, describe the transformation. So a, in this case, is 3. Okay, you can see the number here multiplied by the x. That's our a value. And this would be h. All right, so it's a horizontal movement of 5. So the graph of g is going to translate the graph of f 5 units to the right, and then you're going to have a horizontal shrink by a factor of 1/3. Remember, when it's inside, it's 1 over a. So because this is 3, it would be 1 over 3, which is why you get the horizontal shrink by a factor of 1/3. All right, so if we want to graph f of x and g of x, again, if you do it by hand, you can make a table of values if you want. I'm just using the graphs out of the textbook because my sketches of these curves would not look anything like this. But again, you can make a table of values, choose x's. X is your independent variable, so you can always choose x's for your table, and then take the x's, plug it in to find the y value or the f of x. All right, so if you graph 3, I think that's supposed to be 3 to the x power. Hold on one second. All right, I've got that fixed now. So it's f of x equals 3 to the x power. We're working with exponential functions, not linear. So that was an exponent here. So f of x is the blue line here. F of x equals 3 to the x power. And then g of x, again, is your transformation, moved 5 units to the right, and a horizontal shrink by a factor of 1/3. All right, so it says, look for structure, compare the transformation in example 3a with the transformation of f represented by h of x equals 3 raised to the 3 times x minus 5 in parentheses. So you can see this does not have parentheses and this does. The difference, 3 times x is 3x, and 3 times negative 5, remember distributive property, is negative 15. So this would have a horizontal movement of 10 units more than the one that we did for g of x. B part says f of x equals e to the negative x power, so that's my parent function, and g of x equals negative 1/8 times e to the negative x power. So the negative and the 1/8 have been added to g of x. So what does the negative do? So the negative is going to be a reflection across the x-axis, and then the 1/8 is going to have a vertical shrink by a factor of 1/8. So that's describing the transformation. All right, so reflection across the x, vertical shrink by a factor of 1/8. And what is that going to do? What it's going to look like on the graph. So let's see if I can get the graph here. All right, so you can see this is f of x. And remember, f of x equals e to the negative x. When you have a negative exponent, you can rewrite that as a positive exponent. So this function can be rewritten as 1 over e to the x power. Okay, so remember e, the exponential function, if it's just f of x to the e, is an exponential growth function, but this one's going to be exponential decay. The transformation reflects it across the y, so you can see how that's flipped upside down. That's your reflection. And then a vertical shrink by a factor of 1/8. You can see how that kind of, it's called a vertical shrink, but it looks like it just kind of expands it out a bit here. In my opinion, the shrinks and the stretches tend to be the most difficult for everyone. So if you need to, refer back to your key ideas, refer back to your notes, and just the more practice you do with these, the easier it will become. Example 4, transforming logarithmic functions. Describe the transformation of f represented by g, then graph each function. All right, so f of x equals log of x. Again, this is my parent function. This is the most basic function. What are we going to do for a transformation? So this one says g of x equals log, parentheses, negative 1/2 x. All right, so we have a negative inside the parentheses, so that tells us that it's going to be a reflection across the y-axis this time. And then the 1/2 inside the parentheses tells us it's going to be a horizontal stretch by a factor of 2. Okay, again, it's 1 over a. A is 1/2 in this case, so 1 divided by 1/2. So the reciprocal of that is 2. So it's going to be a horizontal stretch by a factor of 2, and that's what it's going to look like. All right, so we have described it. Now let's see if I can get a graph. All right, again, this is the graph from the textbook. F of x is the blue line. That's your parent function. And then you've got that reflection where it's going to reflect across the y-axis. And then again, you're going to have that horizontal stretch by a factor of 2. And again, if you want to use your calculator to graph these, you can. So if we want it to look similar to the graph here that's given in the book, you can see that it goes from negative 16 to 16. So if you want to change your window, your x minimum is negative 16, the x maximum is 16. And then on my y-axis, I can change that to negative 2 and 2. And I've already done that here, so when I graph, my graph's going to look similar to this. A lot of times people will graph something and then they don't understand why it doesn't look like the picture, but your scale has to look the same if you want it to graph. So if you want to just graph log of x, you can graph log of x, and that's going to be the graph. And it's going to be the blue line here. Now, in your graphing calculator, it looks like it stops right here, but this line actually continues down. There's that asymptote there. So it gets closer and closer to the y-axis. It's not actually going to cross the y-axis, but it does come down close to that. You can see how the graph here is represented like it's doing that. All right, if we want to graph g of x, we can do that as well. So let's graph g of x real quick. So we can graph log. And now we've got parentheses, negative 1/2 x. Put extra parentheses here. Let's go back. I'll just start over. So we've got log of, it already gives me the parentheses, so I'm going to do negative 1/2 x, and then I am going to close my parentheses and hit graph. And that gives you the transformation, g of x. And again, it looks like it stops too, but it doesn't. It just continues gradually down towards the y-axis. All right, so that is how you would graph your logarithmic functions on your calculator. All right, B part says f of x equals log base 1/2 of x. And our transformation, g of x equals 2 times the log of base 1/2 times x plus 4. So you can see that this is the parent function. That's the most basic form of this function. And we have a 2 multiplier, and we have a plus 4 inside our parentheses. All right, so that means a is 2. If a is 2, and this means that h is negative 4. So what that tells us is that we have a horizontal translation of 4 units to the left. So this is going to move us opposite the sign, remember. So it's going to move me 4 units to the left. And this 2 is going to be a vertical stretch. Remember, when it's in front of, outside, it's a vertical movement. So it's a vertical stretch by a factor of 2. So if we want to look at that, All right, again, this is the graph from your textbook because they do a much better job graphing than I would if I was just trying to plug in points and try to sketch this curve here. But you can see the blue line here is f of x, that's log base 1/2 of x, and then 2 times log base 1/2 times x plus 4. You can see how the y-intercept, or sorry, in this case it's the x-intercept, so I'm going over 1, 2, 3, 4. So the x-intercept moves over 4 because I shifted the whole function 4 units to the left. And again, I'm just choosing a point so that you can visually see that they have shifted 4 units. And then this 2, that 2 is a vertical stretch. It's not going to be a lot different, you know, kind of twice as big, I guess. But something else that there's a study tip, it says, notice that the graph as a horizontal translation also shifts the isotope as well. So each time you have a transformation that shifts vertically or horizontally, the isotope will change as well. So you can see the isotope for the original function would have been along the y-axis. Okay, so x equals 0. And you go 1, 2, 3, 4. Now the isotope is at -4. So your domain for G is going to be x greater than -4. All right, again, something to see on the calculator. This one is a little bit different, okay? Remember when you have this function here, it's always base 10, and ln is always base e. We learned that in a previous lesson. So if you want to graph something with a different base, you can't use these buttons here. So very important, if you want to go to graph and you want to graph that, first let's see that this graph goes from 4 to -4, and it looks like 3 to 3. So let's change our window. So my x's go from -4 to 4, so let's change that. And again, I just try to show you these things because using your calculator is very handy, but if you don't know how to use it correctly, it's not really much benefit. So the y's, it looks like the y's are going down to -4, so let's change that. I'm just trying to make the window the same as the one in the book. And this goes 2, it looks like it goes up to 4. All right, now that my window is correct, I can type this in. Now to do a different base, again, remember this is log base 10. We have to go to math. And you can scroll up or down. I'm going to scroll up just because I know where the button is. But if you scroll up, log base, this will let you enter any base that you want, even when graphing. So if I want to graph with a different base, go to math and find the log base button. And then just type in the base, whatever it is, and then the x, and then I hit graph, and that's going to show me my parent function, my f of x right here. If you want to graph this function, you can do that as well. So we're going to go down to y2, which is going to be our g of x. We're going to do 2, and now we're going to do math, and we're going to find our log base button again. And the base is 1/2. I'm going to arrow up to my parentheses, and I'm going to do x plus 4. I'm going to arrow out of the parentheses and then hit graph. And this should represent this function right here. And you can see it's crossing at -3, -1, -2, -3. So this is the same function. Again, if you want to look at the table of values for any function, second graph gives you your table. It shows you an error because it doesn't go past the isotope, and any points above that would be fine. Remember, logarithmic functions are not defined for negative numbers. So that's how you would graph using your calculator.